All right, welcome everybody to Every Rock Has a Story. I am so excited because I am with Professor Hillary Polevsky, who's a professor at Boston College. And Hillary is here today to tell us a really interesting story, a little bit about a rock, a little bit about the ocean. So I want us all to take a deep breath. And I'm going to turn things over to Hillary. Welcome. Tell us about yourself. Tell us about your story.
Well, thanks so much for having me here, Ethan. And it's so exciting to be here with all of these rocks because, as you know, in my past, I was really interested in the stories that books told. I loved reading. I loved learning stories. I loved spending a lot of time outside and learning the stories that the environment had to tell, but I hadn't known that rocks held those stories about the past. Mm-hmm. And when I got to college, I started taking classes where my mind was blown, learning that you could tell these stories with rocks. But then, since then, for the past 15 years, I have moved away from rocks. I started thinking about where the stories start. So I have a rock that is maybe the end of the story that I try telling, and this is a rock that you brought for me, actually.
I did. So the story of this rock that I guess I'm going to finish the story, and you'll tell us the beginning part. I got this rock as a gift from a group of students in California. They live in the town of Lompoc, California. They sent me this rock, which is from a big mine right in Lompoc. And so it's special to me because it comes from some of the kids that have watched my videos. And maybe you guys are out there right now. So Hillary, tell us then the story that leads us up to this particular sample.
So this rock, much like this rock, the chalk that you told a story about earlier, is made up of teeny tiny organisms called plankton. So if you were to get a microscope and look super close at this rock, you would see all these teeny tiny organisms. But this is a different kind of plankton. These ones are called diatoms. Diatomaceous earth, that's basically a rock that is made of diatoms. Mm-hmm. And I love diatoms. If you look at them under a microscope, they are beautiful. In the Victorian era, people actually made art. You would look through a microscope and you would see the art where people would arrange these beautiful diatoms.
Really?
They have really beautiful shells, so they make a shell around them that's made out of glass. And those glass shells help protect them from being eaten in the ocean. And so the way that this rock formed is some of those diatoms sank all the way through the water and landed on the bottom of the ocean. Yep. And they got preserved there and ended up in this rock that these students found in California and sent to you.
That is cool. And I just want to remind our viewers too, so the chalk rock, this was from episode 6, and their skeletons are a little bit different than the skeletons and that glassy coating that you talked about in the diatoms.
Yeah, so these ones are made of calcium carbonate. That's what made it fizz when you put the acid
that fizz test, that was fun.
On that rock. So it wouldn't fizz with this one, but both of them do the same thing that is really important for the ocean and for us, and it's related to that deep breath that we all took at the beginning.
Okay.
Because when you breathe in, do you know what it is that your body needs, that you're breathing in from the air, what that gas is?
I bet you guys know. I think you're going to say oxygen?
It is oxygen. And so oxygen is one of the 2 gases that I spend all my time thinking about as a scientist. I spend time thinking about oxygen and about CO2, which is the climate gas that you talked about when you talked about the chalk. And the 2 are related to each other. So they are plants, just like the plants on land, and so they take in the CO2 and they put out oxygen. Actually, half of all of the oxygen that we breathe when you take that breath, you should thank a plankton for it because it came from a plankton in the ocean.
So a lot of your research, you actually go to sea, you go to the ocean?
Yeah, so a lot of my science, the science that I started out doing, you get on a boat and you go out to sea. And while we're out there, we fill bottles with water and we make measurements of how much oxygen and how much CO2 is in those bottles of water that we're collecting.
Okay.
But there is a trick to that, which is I love going to sea, but I get really seasick.
That's what I think would happen to me if I went to sea.
And I really like studying the cold, stormy parts of the ocean. So we have robots to help us do that job. And I brought with me a little Lego model of one of the robots that I use. So this is much smaller than the actual robot. The real thing that I use is about 6 feet long.
So about as long as the table, 6 feet.
Yeah.
And it looks pretty much like that.
And it looks just like this.
Wow.
And so this is called a glider, but you can think of it as being like a little yellow submarine. And so we put an oxygen sensor on this glider and we put it in at the surface and it dives down, 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 a whole kilometer down, and then it turns around and it comes back up. And when it gets to the surface, it actually sends text messages home, just like the text message you would have in your phone, and it tells you where it is, and it tells you about the oxygen measurements that it made. When it's really cold and stormy, we can keep track of what those diatoms are doing out in the ocean.
And in fact, one of the things I learned about this rock that my friends from that school in Lompoc got for me, this rock is actually a record of the oceans about 5 million years ago. So you or another scientist could look at these ancient remains of diatoms and learn about maybe climate or CO2 or oxygen 5 million years ago in the oceans off the coast of California.
Yeah.
That's amazing. Well, thanks again to Hillary for sharing that story about the oceans, about biology, and about the rocks that record those processes. Isn't it amazing that teeny tiny little plankton, tiny organisms in the ocean are creating the oxygen that we all breathe in the atmosphere? It made me realize and remember that science is all about connections. Sometimes we get inspired by one thing, like Hillary was inspired by rocks as a child, and that leads us to make a discovery of something new that we find even more interesting and exciting, like Hillary's work in the oceans and in that biology of the oceans. Geoscience is a place where we can connect things like biology and the oceans and even rocks and minerals together. So the next time you take a breath, I want you to think of Hillary, and I want you to think those teeny tiny marine plankton in the oceans that are providing that oxygen to us to breathe every day. Bye-bye.